When we have a charged particle move in a magnetic field, we get a curved path. This is because when a particle of some sort, some charge, moves perpendicular to the magnetic field, here I'm going to let the magnetic field be down into the page, we get a force acting on it, perpendicular to its motion. Here we have its velocity, a charged particle, positive charge, and gets a force perpendicular to it. This results in, basically, we get a circle. I'll draw it right here. So here we have a magnetic field going down into the page, downward. We have a particle moving this way with a force acting on it inward. The force acting on it, assuming there are no other electric fields, which will make this a more complicated situation, the magnetic force on it will be, Lorentz force law gives us, Q V cross B, where the x is actually the vector cross product. In this case, we can simplify and simply write QVB. If our where v is the part of our velocity that is entirely perpendicular to the magnetic field. If there is a part that is parallel to the field, we'll get a spiral instead. But this equation will still work, and the rest of this problem will be the same. Now, if we want to find out what the radius of this is, and how long it takes for it to go around, that's called the period, then we can solve for that. This is actually a very common situation in nature, and which makes this a very useful problem to solve. We start with the centripetal force, which we can write as m v squared over r. We set this equal to the Lorentz force equation, because this is the force that is actually supplying the centripetal force. The force is actually pulling it into a circle. We write Q, V, B. Now, if we want to solve for r, we can multiply both sides times r, and then divide both sides by QVB. We get mv squared or QVB equals r. Cancel out when the v in top and bottom. We get mv over qb. Just to clarify, m is the mass, v is the velocity, q is the charge, electric charge, b is the magnetic field. This gives us the radius. Now, in order to find out the period, or how long it takes for a charged particle to go around this circle, we will state that the velocity, of course, is distance divided by time. The distance around the circle is called the perimeter. We know that, or the circumference, in the case of a circle. The circumference of a circle is 2 pi r. Now, the time it takes to go around the circle is known as the period, which we denote by the letter t. Now, in order to solve for the period, we take this equation for v, we can plug it into our equation for the radius. So we'll take m over QB. And instead of writing V, I'm going to write 2 pi r over t. Well, the first thing we need to do is simplify. So we can do that by dividing both sides by r. Divide by r, divide by r. R cancels out, which leaves me with, oh, no, I'll multiply both sides times t as well. T over t cancels out. This leaves us with 2 pi m over qb equals t. We have the period.